Hello. Okay. So I don't hit stop record. All right, hey everyone. My name is Tian, and well, welcome to the CPSEC meeting. And today we're going to be talking about BGP security. Just a little bit about me. That's me. I'm a fifth-year computer science major doing a master's program, mostly looking into internet infrastructure research. So kind of BGP. So that's why I'm kind of talking about it today. Just a little bit more about me. I run the CTFs, or Capture the Flag team, so that's kind of what keeps me occupied most of the time, along with my schoolwork. I like film photography, hiking, backpacking. This was a picture I took when we were out at HIJACK a couple of years ago, so I really like that. It was a good trip. That's me and my family. Yeah. For the agenda today, we're going to be talking about what is BGP. So you'll learn a little bit about that. What does it actually mean and what does it do? We're going to be going over some security vulnerabilities inside of BGP and what are those implications, and possible improvements that have been drafted or proposed to address those. We'll do a Q&A and demo. Well, we'll see if we get to the demo. Yeah. So yeah, what is BGP actually? Okay. I'll start off with defining what does it actually stand for. BGP stands for the Border Gateway Protocol. Now for what does it actually do, we're going to need to get some context. So let's jump to how does the internet work? One way to simplify it is to say that we're going to have computers talk with one another. Now whether that's like my computer talking to your computer or my computer talking to like some far-flung Amazon server, that's something, that kind of defines the scope of like what you're doing and what the use case is. But for the internet to work, computers need to talk to one another. In order for this to work, my computer needs to know what's the how does it tell the difference between your computer and some far-off server owned by Amazon. One way to one important part of this is to actually have unique identifiers. So I don't mix up your computer with someone else's computer with some random server. We usually do this with in IPv4. It's just a unique way of addressing in the internet space. And so if you have an assigned number, that's distinct from any other number. These numbers are 32-bit numbers, so there's like, if you take introductory computer science classes, there's bits, and there's 32 of them, and that composes like a really large number. Interesting though, IPv4, as some of you may know, is often not a large enough space for us, and so obviously there's other complications with that. Hence why there's things like IPv6, but we're not going to go into that. Basically, just know that we're going to be working with IP addresses. In order to address to certain individuals or devices. Now, there's a lot of possible numbers that you can use, and these possible numbers can be often chunked together or grouped together into certain spaces. And one way that people chunk or like group those together is with this notation. I actually forget the name of this notation actually, but we learned it in computer networks. Jackson, do you know?
It's called CIDR notation.
CIDR notation, yeah. So, I don't know if I want to go into explaining it. Okay, so let's just say we have this IP address or IP range here. This is actually the IP range of Spectrum Wireless. I just looked up like who's, what's my IP, and then who's the, who kind of owns the IP address, I suppose. We can think about that. But who owns that really? And I just looked that up, and that's Charter Communications or Spectrum Wireless. They have this fancy number down here. We can go into that later. But basically, they own everything inside of this range. And the important part is that there's kind of there's like numbers in the front, and then there's some leading zeros, and then there's the /18. So the important part really is like that /18. So you can think of it as the first 18 bits in the very front, kind of, that's the range that they control, or that's kind of the specifier for what they are. And then everything else after those 18 bits, that's room that they can work in. That's stuff that they own, and so my IP, like the IP address that I had is inside of that range. I also threw it into the calculator in Mac, and if you put it into the, I forget which mode it is, I think it's like Command 4 or whatever, it shows the little bits at the very bottom, so you can, it's hard to see, but yeah, there's bits set in order to denote this specific range. And then after a while, a lot of those leading zeros at the very end can be played with in order to address. Yeah.
How does like a company go about buying a specific IP range?
That's a good question. We can go into that in 2 slides. 2 slides, yeah. Okay. So yeah, there's IP ranges. Someone owns them, and you know, there's some sort of hierarchy, I suppose. Someone's controlling this range of IP addresses. You know, in that sense, maybe I don't own the IP address that I'm using right now. So, you know, how does that actually all work, and how does that play into BGP? First off, when we were looking at this earlier, I said, okay, there's this funny number down here, 20115. That's the number assigned to this IP range, or yeah, I guess yeah, that IP range. And so that number is what we call an autonomous system. Well, we call it an autonomous system number, really, but okay, those numbers denote autonomous systems. And so here's a dictionary definition. A autonomous system is a collection of connected internet protocol routing prefixes, okay, the IP ranges, under the control of one or more network operators. So that would be someone like Spectrum Wireless, as we were talking about earlier. But as we'll see, there's kind of a nested nature of this. So let's say, okay, in this scenario, or in this kind of graphic, we can see, let's just pay attention to the purple boxes. So those denote those autonomous systems. If you can see, I realize it might be kind of hard to see with the purple text on the purple box, but yeah, Continental Broadband there has a /20 of that IP number, and then above them, sitting above them, is Sprint, who have a /12. If you look at the numbers, you can see that actually the IP range that Continental Broadband owns is inside of Sprint's. So in that sense, Sprint kind of is an umbrella above many other autonomous systems that are underneath it. So we have this other one, ETB-SA ESP, looks like, I don't know, it's a different country, but it's not in the United States. However, both Continental and this other autonomous system are under the same umbrella under Sprint in the 63.160/12 kind of address space. And then that goes further up to this organization. Okay, think about this. This can nest as far as down as you want. Actually, there might be some limit set somewhere, but that's another complication, yeah. But at the very top, we have something called ARIN. And so for us, that's the American Registry of Internet Numbers. And so that's just the body of, I don't know if you call them network operators, but it's the body of individuals, or the controlling body that controls that address space. Actually, now that I think of it, I don't really remember what the entire address space for ARIN is. However, ARIN's not the only one. It shares it with a lot of other different, different kinds of geographic organizations. So we have ARIN for North America, LACNIC, LACNIC for Latin America, RIPE-NIC, or RIPE-NCC for Eurasia, Middle East, AFRINIC, and APNIC. And underneath all of those in other regions, there's something called National Internet Registry, or I don't know what they call them, National Internet something, NIC. But anyway, those kind of sub-organizations, they kind of play the same role as these regional internet registries, but there's just for like a single nation state. So Mexico has their own one, Chile has their own one, et cetera, et cetera. This is kind of how the internet is structured. Oh, and then at the very top we have IANA. I also forget what they stand for, but they're like the big organizing body that like decided all of this basically. You know, so they're kind of the big head honcho kind of people. So they kind of distribute it across to these regional internet registries, and they the regional internet registries then distribute it to other autonomous systems who can distribute it further and further and further Just however, as long as you have room, you can distribute it and rent it out and make money. That's just how it works. And it just works because we all agree that it works. It's that kind of thing. Yeah. So yeah, that's great. That's how the internet works. Where does BGP play into all this? So we have all these autonomous systems here, as we see. However, on the global scale, things can get very complicated. This is just a graph representing a bunch of autonomous systems and their links to other autonomous systems. And so this looks very complicated. Each little number, that's like on a single autonomous system, and the green links are their kind of links out to it. So you can see that there's ones that are maybe at the center, like 17676. There's a lot of branching nodes coming out of that. I think they're also denoted by the circle. You can kind of see. However, this complicated example is actually just a representation of Japan. That's like one country, okay? So, like trying to like coordinate, a way for internet traffic to go from one computer, traverse something far complicated than this, because you're thinking on the global scale now. How is that actually going to work? How does the internet traffic decide, hey, maybe I should use that green link over there instead of the one that's right next to it? How is it going to choose actually? How it's chosen, that's a complicated matter. How do we actually distribute that information? That's a far simpler thing. That's something that's covered by BGP actually. Let's see. Yeah, you can go to that here. So really what BGP, or the Border Gateway Protocol, does is it shares information on intradomain paths to specific IP prefixes, or those IP ranges that we were talking about. So really what all that includes is the AS path and the next hop. So the AS path, you can just imagine that as being, okay, this is the pathway that you can take to get you can take through me to get to this certain IP prefix. So Spectrum Wireless could say, hey, if you want to get to Tian, like this is how you can do it, and this is kind of like the steps that you could take to get to him. Obviously, like if Spectrum Wireless, if my IP address is just inside of their space, like directly that they own, then that's like trivial. Just a one, their AS path is just them. But if they knew about me through another autonomous system, they can still distribute that information through this AS path. So you can distribute information about people that you don't, well, not specific people, but those ranges that we were talking about. They can distribute that information for prefixes they don't necessarily own, but they know of. Yeah, so BGP, the packet data that's actually sent out, it's usually just in the form of updates to the paths that are already established. They can withdraw those routes. So they said, okay, I said that route exists, but actually it just doesn't actually exist anymore for any reason, then they can withdraw them. And then they can also send like periodic like what do they call them? Like I guess pings, just to make sure that hey, I'm still alive and like this route still exists. So that's on a periodic nature. There's a name for that. So yeah, that's just kind of the gist of what BGP is and what its purpose is. So now we can go into what are the security vulnerabilities, hence this club. What what are the vulnerabilities in the system and what makes it, we've seen how important it is, but like what does that actually mean for us as users of the internet? I've also never seen Star Trek, but the screen grab is really funny, so yeah. So yeah, what's really the big deal? There's lots of attacks that we can perform on this kind of large system that we have. One thing to note is that nowhere in that kind of specification that I was talking about earlier did I have to, did any single party have to say, hey, this is me actually. There's no authentication really at any point in that process. And so if you think about it, anyone can really announce anything they wanted, and there's no way for anyone to really validate that information or like, I guess, report them for that kind of information. Like they can go, I guess, to the higher bodies like IANA, I suppose, but actually tracking that information and making sure that the people that you're talking to, those announcements that we were making earlier are actually correct, there's maybe not such a clear-cut way to do that. Yeah, so attackers can really advertise anything they wanted. If you're in a, if you owned your own IP space, maybe out of incompetence or malicious action, you can announce BGP updates that are not actually true for the IP space that you own or the current state of the network. So yeah, there's just none of that built into the protocol. It's just kind of, right now the current system is, I trust the autonomous systems that I'm peering with right now. And so, why would they backstab me kind of deal? Yeah.
What does peering mean?
I don't know if I want to go into that.
Okay, how about a brief, a little quick definition maybe?
Yeah. So let's just say that my autonomous, let's say I'm an autonomous system and I'm talking to someone else. And then in that sense, maybe in that relationship I'm talking with someone, they're not necessarily an autonomous system that kind of is renting out space from me, but we kind of have this we have this agreement that, hey, I can share the routing information that I have with you, and then they can share the routing information that they have with me, and so we kind of grow out our networks of network availability so that my customers can talk to your customers and vice versa. That's kind of the gist of it. Yeah. But yeah. So in the case of okay. Okay, now we can go on to, okay, how is this information leveraged? Well, the actual routing procedure that takes place is actually often done based on, routing protocols or routing policies that you set yourself. And so, as we were talking earlier, these IP spaces have these slash notations to them to specify how specific they are. So a /24 is a smaller space, but it's a more exact space than maybe a /20, which has more room to play with. And so you could say that the /24 address, or the /24 address space, is more specific in that sense. And so in that case, one often used, routing policy is to say, hey, if one of my neighbors knows a very specific knows a route to a very specific subspace that I want to go to, I'm going to take that route. That's a decision that you actively make as like a business organization. Another decision that you can make is say, hey, okay, we're looking at the AS path. Well, I don't really want to have my traffic jump all over the place. I actually want to have it, spend as least time as possible traversing this network in order to get to its end destination. So I'm going to take the shortest route possible. Okay. And there's other business policies that you can have set. I think various U.S. organizations, there are nation states that they kind of blacklist as like, okay, internet traffic just can't, internet traffic from the U.S. can't traverse through these countries. And so that's something that we need to know about and account for, even if that route might be like the quote unquote best according to these other specifiers that we're talking about here. Like if it's the shortest, but it's not a country that we want our internet traffic to go around or go through, we're gonna have to go around it. And that's just a decision that we have to make. So yeah, those are all like kind of, those are all very specific decisions that have to be made by each business organization. And so this creates kind of room for bad actors to come in and slip in and wreak havoc. So one such attack, cyber attack on this, is the shortest prefix hijack attack. And so if your organization or if you are routing on some sort of level according to, okay, we're going to go for the most specific route, an attacker could just they can create a false announcement saying that, hey, I have an even more specific announcement. You have the /24, I have a /25. I have that more specific address or that more specific end destination that you want to reach. You should come to me. And so in that way, they can draw traffic that is destined for that, for those IP ranges to themselves, even if they're not the genuine, or they're not the intended receivers of that information. Now, how you actually leverage that, that can be, you have the traffic now. What are you actually going to do with it? Maybe you can forward along to the actual real intended destination, act as like a man in the middle. Maybe you can just black hole all the traffic if you wanted to. There's just a lot of attacks that you can go forward with from this foundation. Yeah.
Wait, so for the /24/25, so if a node has /24, is the actual /25 going to be under that node?
Yes. So like if you, I guess one way to think about it is that, okay, if there were two real autonomous systems, one was the /24 and one was the /25, and they both have the same, obviously they have the same the numbers in the front, so they're all kind of going towards that same area, then the /25 would be a customer, or like they would be underneath the /24. But obviously, if you have another route coming in from somewhere else, that's maybe more, it doesn't necessarily need to go through the parent to get to the child, because again, we're talking about peering.
Yeah.
You can have other routes to get in.
Okay.
So, there's advantages, obviously. There's a reason why these network operators are choosing these kinds of networking, routing policies. But of course, they can be leveraged since BGP doesn't have that kind of validation built in. You just kind of trust that, of course I'm going to trust them, but that kind of more business, business operations kind of trust not being built into the protocol does open up some vulnerabilities. Yeah.
Why is there no validation in the form of just like trusting the parent where the child nodes are?
That's just how it is.
Is that because of the peering thing, or?
I mean, that's more of like a protocol level thing. Like, in other parts of the presentation, we'll go into possible improvements, and so there's been other work that's been done to say, hey, how can we build in this trust that we need into the system? And so they do that on the protocol level, where it's like, it's not just saying like, oh, Google would never do that to me. Going beyond that, saying like, okay, Google would never do that to me, and they can't do it even if they wanted to, kind of deal. Yeah. But yeah. That's kind of just a little bit of flavor of like what possible vulnerabilities are out there for BGP. So what possible improvements? Okay, yeah, possible improvements that we can make towards this protocol that we have. These often come in the form of security extensions. So these are, I guess, extensions to the existing BGP protocol, because the protocol is standardized. I think by the IETF. Not quite sure. I heard there's a body that controls that. But they can just draft up new standards that network operators can implement to secure their communications. And so there are several of them, and we can cover them really quickly. I'm going to see how much time we have. 6:40. Okay, yeah, I'll speed up. We have ROAs, or Route Origin Authorization. And so really what that, really what this does, it creates kind of they call it a offline, out-of-band verification method. And basically what it does is it maps your autonomous system number to the address space that you own. So here, okay, in the bottom right of this image, you can see that this IP address kind of, that prefix that we have is being associated with that number that's at the very top of the bubble. And so, so that kind of mapping is made. And then this is all authorized by your regional internet registry. So someone like Aaron or APNIC, that high level, they're authenticating that, hey, okay, this autonomous system owns this prefix space. And so if you see someone advertising saying, hey, if you want to get to this address space through, if you want to get to this address space, but the autonomous system at the very end of the pipe does not match what you expect in this database, then you know that, okay, they're not the genuine owners of this address space. I could ignore that, or that's either maliciously crafted or something went horribly wrong, and I can just safely ignore that, and ignore that announcement to update my routes. And so that's one way that rows can work. However, they're not, how do I say this? you can always just make up your autonomous system number. So like you can just change the autonomous system number. In this image, you can see that okay, the route that's being announced, the very end of it is being changed to the genuine, receiver, and so this is now a they call it RPKI valid because row is part of RPKI. They call it an RPKI valid route now, or valid announcement now. And so now this announcement is now quote unquote valid, even though it's obviously not, because it's going to still do the same, it's going to have the same impact of like drawing that traffic in, and now you can do whatever you want with it. There's more that we can go into about like, okay, this is actually more limited than maybe the previous attack we were talking about earlier, but I'm not going to go into that now.
With this form of attack, in this safer infrastructure, would this attack not be able to perform black hole kind of thing? I guess I will go into that. So they can still black hole that traffic that's intended for the genuine destination. However, it's restricted because now now they can't just say, hey, I have a more specific address, everyone should come to me. They can't do that anymore. Now it's more along the lines of, hey, I have a valid route to get to your end destination, and so do they. And so now you have two competing parties. And so now you're only going to get a fraction of it. And as it turns out, the tiebreaker in most situations is path length. And so they're going to take the shortest path length realistically. And so realistically, you can only draw in the information or the packet data of people that you are peered very closely to. Yeah. So if you set up a connection with a trusted site that's very close to the vulnerable system, then you could shorten the path enough to redirect all the traffic.
You can mess with the network topology in order to get a more favorable position to draw in more traffic. If you set up operations in a place that's less desirable, then you're going to draw in less traffic. But now, because oftentimes we'll use the more specific prefix space. So now that RPK or rows are being implemented, now you don't necessarily have that guarantee of drawing in all the traffic. Yeah.
So you were like in Japan, and then the machine you were targeting is in USA, and then you say that you have the route to that end destination. Wouldn't all the traffic in Japan just go to you, and then you could stop? Or am I misunderstanding something?
Can we cover this after the meeting, because I think I need to think about that for a second, because I was confused where are you and where's the attacker in that situation? Yeah.
So I'm the attacker in Japan.
Oh, you're in Japan. Okay.
Yeah. And then the machine you're targeting is in USA, and then you say that you have the route to that machine
in the U.S.
In the U.S. Wouldn't all the traffic from Japan just go to you, because it's a lot shorter than the alternative?
Oh yeah, because so you're masquerading as the person in Japan, basically. Yeah, in that sense, I mean, at that point, it depends on the routing. Yeah, it depends on the routing topology, but most likely that sounds about right. Yeah.
So if you want to target someone, can you just stop half of the packets being sent to them? Is that possible?
I mean, because once you're drawing in that network traffic, you can do anything you want with it.
Right.
It's it's only going to you at that point. What you choose to do with it is up to you, and what your desires are at that point. What kind of attack are you trying to create here? Because if you're just blackmailing the traffic, eventually they're going to catch wind of hey, if I send my traffic there, the web page is not loading, something's up, I'm going to go to that other route. Because at the end of the day, users are still looking for functionality, and so maybe creating, obviously there's use cases for doing that kind of denial of service attack, but if you're trying to create a more sophisticated attack, there are means to do that. Yeah. Okay, cool. Another step up from ROAS is BGPSEC. This is another extension that's been written up.
and basically the gist of it is that, hey, you know, a large weakness in ROAs that we were talking about earlier is that, okay, yeah, you know that you own this one specific, like, yeah, you own this one specific range, but we can't really validate, you know, what's going on in that path. Like, what's the path being taken to get to you at the very end? We don't really, you know, there's no real way to validate that in that scenario. So BGPSEC does this through digital signatures. I don't know, we haven't taken 321, I guess. It'll be hard to explain. But basically, we're going to like guarantee that every single step of this path that we're taking is true. Okay, that, you know, in a similar way, all this information has been validated and like authorized by your regional internet registry. So you know, you have to trust your internet. You have to trust the RIR in this case. But if you trust them, then they can authenticate this information. You know, they can verify this information, and now you can go through every single announcement that you get and verify that each step being taken is true. Okay, now. There's clear security benefits in this now that you can verify the route that's being announced to you, saying like, okay, this is one that is valid, those connections are real, and you know, so that's something that I can incorporate into my routing. However, there are some downsides that do exist. One of them is computational, you know, overhead. This is all being done, you know, by the routing infrastructure that you have. And so if you get an announcement from someone and you have to go through every single path, you know, every single link in that path to verify that information, that's just a lot of work that you need to do. And yeah, I guess, you know, often, you know, you don't hear about BGP related, you know, vulnerability news, you know, vulnerability attacks in the news that often. Well, you hear about it, but it's not like super common. And so there's just not that, you know, economic or business incentive to actually like go and implement something like this when it comes at such a high cost of like your day-to-day operations are being, you know, possibly bogged down by this, you know, augmentation that you're making. And you know, furthermore, you can always just say, hey, you know, you can just like say, hey, I don't actually know how to use BGPSEC. I don't have that infrastructure implemented. I only know how to use BGP. And then you can just downgrade them to regular old BGP and just do whatever you were doing earlier. Yeah, the way that BGPSEC works, I mean, there's papers on this, but basically the way BGPSEC works is that unless there's a high percentage of adoption of it, the efficiency, you know, its efficacy kind of doesn't scale as rapidly as maybe the other extensions that we were talking about earlier. And so, whereas ROAs, as we were talking about earlier, have some adoption nowadays. I think it's about 40% adoption as measured by some people. BGPSEC is realistically not being deployed today, right now, for that reason. Yeah, and then, let's see, what time is it? Oh, how much time do we have? Okay, I can go into this. Yeah, and so the last one I'm going to cover for today for these security extensions is called Autonomous System Provider Authorization, ASPA. So they kind of do a lighter weight version of what BGPSEC is doing. You're still going to be saying that, hey, you know, this path information that I'm advertising, it's kind of hard to see. Yeah, sorry. But you know, we're still going to say that, okay, this is someone that is my parent that's above me, and so they kind of own the space that I'm a part of, and then that can be nested, you know, of course, you know, further and further. But that information is being validated again by the RIR that you're kind of like in the region of. And so while you're not, what do you say? So you know, you're not getting that kind of peering information in there, and so you're not getting the whole picture in that sense. But you know, like we are with BGPSEC, however, you're still getting kind of some hierarchical information of like, okay, who is above who, and who can kind of like, what are those genuine links looking like in the real world? So you can kind of get that information, and you can make routing decisions based off of that. This extension specifically is still being drafted up right now. It's kind of what my thesis is on, but these other ones have already been drafted up and have been standardized already. So if you want to go look at them, you can. I don't know if you like looking at standard papers in your free time, you can. But yeah, they all kind of have, well, they all have their benefits and drawbacks. And so we're kind of seeing how they are being deployed in the real world right now. And so as for, what their actual deployment rate is going to be in the near future, that's just something we're going to have to see going forward. It's just kind of based on business policies, what are network operators feeling are their priorities for their organization, and what are bodies like IANA or like Aaron doing for all this. That's just, just a lot of parties involved. So it's a very interesting space, and so I think there will be some changes possibly in the near future, but who knows. But yeah, we can just do a quick summary. BGP, I hope you've learned, if you take anything away from this talk, just maybe, knowing what BGP is would be great. BGP is used to configure interdomain routing, so that's kind of like the routing between all these different bodies. There are some, security vulnerabilities that we were talking about earlier, and work is being done to upgrade it. Whether that's good work that's going in, that's maybe up for debate, but there is active work being done here. And so maybe it's an interesting space to like look into. Maybe you can do it like me, like a thesis, or you can just do it in your own time, just like read a Wikipedia page or I don't know, just read something. And interesting space. And adoption is slow, but the work in progress. Yeah.
You mentioned, I don't know if you mentioned this earlier, but why is adoption slow if it's highly insecure? Shouldn't this be a priority for people since it's like very widely used?
These security extensions, their adoption is very slow. As I was talking about, the oldest one, RPKI ROAs, I forget what year they were like standardizing it, but they were standardized like, I think it was like decades ago. It might have been 1 or 2 decades, I don't know, but it's been a while and it's at 40% deployment.
Okay.
And like, as we were talking about earlier, it looks pretty simple. Like you just go to your RAR and say like, hey, I have this address space, I can prove it. Can you put in your database that says that I own it, and that's all you do basically. I mean, you have to do some validation steps, of course, in your day-to-day operations, but that's kind of like the lead-up work you have to do to it. And a lot of network operators are already doing this. They're doing it in a way, I forget the name. It's just another database that they're going to and saying, hey, this is like the address space that I own. You can go to this database and verify that that's true when you're doing your routing decisions. However, that database that they're often going to is just some random database that's owned by people, and so they don't have that authority of maybe like Aaron to go and say, hey, this information is actually wrong. We're gonna remove that information, or you're submitting bad information. We're gonna blacklist you or like revoke your space or whatever. They don't have that authority. So, I mean, I guess I haven't looked into it, but like maybe bad actors can go in and just put faulty information in, or if people just don't update their information in that database, like it would just be outdated information that's in there. So like there's there's already simple augmentations that are being deployed. However, people aren't really adopting them because they don't see it as critical to their business operations. But you're using the internet right now and it works. So I mean, I don't know. I guess from a lot of people's standpoint, if it's broke, don't fix it. Or if it's not broke, don't fix it. So yeah. If you want to, some cool links you can go to. The 40% adoption rate, you can look at it right there. The RPKI monitor. You just look at it. It's just like 41% adoption, and it's kind of sad, but I mean like it's better than what it used to be. So that's good. Cisco BGP stream, you can look at routing incidents or like those kind of suspected attacks. They kind of document those, and so you can see like kind of a network simulation of like those attacks going on if you want to look at those. And it's not in real time, but it's like you can look at events that are from like a couple of days ago and like see what's going on. So that's kind of cool. And then IP info at the very right. If you want to like go and look up who are the autonomous systems in your area. I think that one QR code goes to America, so if you want to see like the autonomous systems in America, kind of look at that information if you want, that would be kind of interesting. And yeah, that's all for me.